we're graphing functions from vertex form today. So remember that vertex form is just a transformation of the original parent function, which is y equals x squared. And all of these things do something different. So the x is inside the function, so it's going to move the function left or right. The k is outside the function, so that means it affects our y values. It's going to move things up or down. And the a is also outside our function, so that means it's going to stretch or compress our parabola. Now, in theory, you could have something in here with the x that's going to stretch or compress it horizontally, but we don't often see that, and we're not going to see that in Algebra 2. So really, this is our vertex form. So with one of these, let's see what we did. So first, we have this -1 in front of as our a, so that means we take all of our y values and multiply them by -1. So first we're going to multiply y by -1 because it's outside the function, and since y doesn't lie, it does exactly what we see. So that's our first thing we're going to do. The second thing we're going to do is we're going to once we've done all of our multiplying and dividing, then we can go on to the adding and subtracting. Just like order of operations, we do all of that first, and then we do our shifting, okay? So then we shift. Let's see. We went left 2 because x is a liar, and since your x is a liar, it's going to shift to the left 2 instead of to the right 2 because we do the opposite of what we see. So we're going to go left 2. And then we're going to go up 1 because we see that that's outside the function, so it affects our y values. So let's do that. Here's our parent function. Remember, the pattern of the parent function is over 1, up 1. And then you go back to the vertex, you go over 2, 1, 2, and up 4. 1, 2, 3, 4. Okay. Now, the first thing we're going to do is multiply all of our y values by -1. So when I take my y values, see this y value is 0, so it stays where it is, but this y value is +1, so at this point, the x value stays the same, which is +1, but then the y value becomes -1. So that's the same for both of those points. And then the second point, we're going to go over 2 and down 4. So we didn't actually stretch or compress it. That negative just flipped it, okay? And then we're going to move left, what was it? Left 2 and up 1, okay? So we're going to move left 2, so that's going to go here, and then up 1, so that's going to go here. And then we didn't stretch or compress it, so this one actually still has the same pattern as the original parent function, and that pattern is over 1, down 1, over 1, down 1. Over 2 from the vertex, over 2, down 4. 1, 2, 3, 4. So this green function is actually our final transformed function from vertex form. So it's going to be the actual function that we see up here. Okay. Now let's figure out some of these things, some of these features of the function from the graph, or we could have figured them out from the equation. What's our axis of symmetry? Well, remember, the axis of symmetry is just this invisible line that cuts our parabola directly in half, and we could fold it over that. So our axis of symmetry is also on the vertex. Do you see that? So our axis of symmetry is the x-coordinate of our vertex. So our axis of symmetry is -2. Because that's, we shifted it that way too, right? Our vertex is -2, 1, because remember, vertex form tells us our vertex. And you can see it right here. The difference is we see the opposite of 2, and then we keep the y-coordinate the same. Direction of opening, remember the direction of opening has to do with our a value. We can see right here that it opens down. But if you remember, if our a value is positive, we're going to open up, and if our a value is negative, we're going to open down. So this is negative, so we're going to open down. Our maximum and minimum value, remember that maximum or minimum value is just the vertex, right? But we're talking about how high it goes or how low it goes. So we're talking about the y-coordinate of our vertex. So what's the y-coordinate of this vertex? Well, it's 1. So our max, because it's upside down, is 1. And then we're going to look for our zeros. This one's very convenient because our zeros happen to be right there on the graph. So I'll show you from the graph, and then I'll show you algebraically how to find them. Our zeros are at -1, 0, and -3, 0. And then our y-intercept is also right there on the graph. It's 0, -3. But let me show you algebraically how to find those. So if I had this function, y equals -x plus 2 squared plus 1. If I wanted to find the zeros of this function, remember zeros are wherever y equals 0 because it's where they cross the x-axis. So I can just set y equal to 0, and then I can solve. So I can subtract 1 from both sides. And then I divide by -1, so I have 1 equals x plus 2 squared. And then I take the square root of both sides, so I have the square root of 1 equals x plus 2. And remember, the square root of 1 is just plus or minus 1. Since I took the square root of it, I have to have that plus or minus because whenever you take the square root of a number, you could have the positive number or you could have the negative, right? Because positive 1 squared is 1, and -1 squared is also 1. So I have here x plus 2 equals -1, or x plus 2 equals +1. So I can solve that. So I say I subtract 2 from both sides, so I have x equals -3, or also x equals -1. So that's the way I could find it from the vertex form. That gives me the zeros. Another way I could have done it is I could have taken it into standard form by multiplying everything out, and then I could have factored it, and it would have given me those zeros as well. And then the y-intercept, everyone always freaks out about these intercepts, and the x is a little bit complicated, but the y-intercept is actually the easiest thing you'll ever find. Because if you think about it, the y-intercept is just where x equals 0, right? Because at the x-axis, or at the y-axis, x equals 0. So all I have to do is plug in 0 for x. It's like I plugged in 0 into my toaster, and I need to see what comes out. So I get y equals -2 squared plus 1. Okay, and remember exponents come before multiplication, so I square that first. So I get y equals -4 plus 1, which is y equals -3. So that's my y-intercept as well, if you can't see it from the graph. So there you go. That's how you use vertex form to graph a parabola.